Welcome to the final class on derivatives. This is derivatives 6, the sixth class. And let me review, or at least review the topics of what we've covered so far. So in the beginning of this unit, we had limits. And limits then led us to the definition of the derivative, which is called the delta process. That's where we have f of x plus h. The delta process is when we approximate the secant line with such a small distance between the 2 points that it becomes the tangent, and that's the derivative that we've been working with since. Our shortcuts for the derivative are the power rule, the constant rule, the product rule, the quotient rule, the chain rule. All different rules, none of them difficult in themselves, but sometimes when you combine them, it's a little bit tricky, but nothing you can't handle. Of course, the limits that I just talked about, there's different types of limits. There's limits as we approach a number. There's limits as we approach infinity. There's limits as we approach 0, which is a little bit of a special number most times. And going back to our derivatives, we did our mixed derivatives, higher order derivatives, so first, second, third, fourth, fifth derivative. We have done implicit differentiation, which is where we have y in the middle of the equation and we get a y prime value out of it. And today we are going to finish our tangent and normal lines, which is actually a pretty simple topic. We've done most of it already. And finish our final topic, which is called rates of change. So in short, if you have the definition of a function, it will give us our velocity and our acceleration, which connects us back to the physics that you might have taken before. So that's the big picture. Let's get to the normal line. So like I said yesterday at the very end, we know what the tangent line is. The tangent line is this blue line. It's the line that just touches the function, and we can get the slope of that line right on the function. The normal line is like the brother or the sister function. It is not the tangent line. It is perfectly perpendicular, so perfectly 90 degrees to the tangent line, which in different applications in math, it's quite important to know it. But for today or for this math course, we actually don't get much further than just getting the equation. So the steps for the equation I went through yesterday are the exact same as getting the tangent. The only difference, let me just talk about that. You get the derivative first, and then you put the given point in. Then you get the negative reciprocal of the slope, which means make it negative, flip it upside down, and then you do y equals mx plus b to get the equation. Let's jump right into a question on this so that we can figure out how these questions are done. Let's read the question carefully. Find the equation of the line normal to the hyperbola. So first of all, find the equation of the line normal to the hyperbola. It means find the equation of the normal line, which means the perpendicular line to this function. This is our function, and we've been given a point at the point 2, 1. So our steps are going to be exactly the same as what we've been expecting. First step, get the derivative. Well, first things first, I'm going to rewrite this, I should definitely rewrite this. What's it going to be? Basic skill. How do I change that into power form? I keep the 2. I bring the 2 up. I bring the x up. Make it 2x to the negative 1. All right, fundamental skill. Sorry, I got a bit of itch here in my eye. Fundamental skill to change that form. Once we do that, it's very simple. What's the derivative? Y prime. We get the derivative of this. We bring down the negative 1. It becomes negative 2x to the power of negative 2. Simple. Second step. Substitute in our x value. Our x value in this case is 2. So y prime, when x is 2, is negative 2 times 2 to the power of negative 2. This gives us, negative 1 over 2. That's exactly right. The whole reason for that, and let's not forget what the derivative gives us. The derivative gives us a slope. So by putting in an x value, it gives us the slope at that point, which is going to be the slope of the tangent line. The slope of the tangent line is negative 1 over 2. That's not what we want. Let me see, Ibrahim, you said y2 is negative because, you mean for this step, I assume. My original function was this. If we get the derivative of that, the negative 1 comes down and multiplies. It's negative 2. The x stays the same. Reduce it by 1. Yeah, I think you see negative 2. Got it? So I'll just erase that so that I don't have too much going on here. Don't want anyone getting lost in my workings. So what I was going to say was, we now have the slope of the tangent line. This is the slope of the tangent. At that point, we don't want that. So our third step is to get the negative reciprocal of the slope. Negative means make it negative. Reciprocal means flip it upside down. So our slope of the normal line, well, it's already negative, so it becomes positive. And instead of 1 over 2, it's 2 over 1, which is 2. That's our new step. Clear? The difference? That's our only difference. Everything else is exactly the same. So our fourth step, use y equals mx plus b. I need to put my y value in, my m value in, my x value in. So my y is 1, my m is 2, my x value is also 2. I'm solving for b. This is 1 equals 4 plus b, so this must be negative 3. Thank you, Mohammed. I think negative, yeah. Let's see that. In case you're lost, let me color code this. My x value is this. My y value is 1. And my slope is m, which is 2, just so that we're all clear. That question's not finished. I need to write my final answer. Y equals mx plus b. Just replace m and replace b. That's my final answer. It's the equation of the tangent line. This was the slope of the normal. Repeat 3. Okay, I can repeat 3. Let me just go off to the side. If our slope of the tangent, let's just say it was 2. Or let's just say it was 1 over 2. The slope of the normal line, we'll flip it upside down. So instead of being 1 over 2, it's now 2 over 1. And we also make it negative. So in other words, the slope would be negative 2. All right, just flip it and make it negative. Same thing if we had a already negative value. Maybe the slope was negative 3 over 4. Well, the negative reciprocal, it's already negative, so it becomes positive. It'll be 4 over 3. You see what's happening? So that's all there is to it. You don't need to do any math, really. You don't need to show any work. You can just go directly to it. So hopefully that makes sense now. It was negative 1 over 2. That becomes positive 2 over 1, which is 2. Well done. So let me show you what this function looks like on Desmos, because that's how I roll. I think it's very important to know what we're doing here. So let's get the function graphed. This is our function. Okay. The point is 2, 1. I can see it on my function. I want the normal line to that. And so let's see, if I was going to make the tangent line, it would look sort of like, no, not like that. That would be my tangent line. I'm going to guess at what the normal line would be. And I'm going to say that. It's not a very good job. Let me try one step further. That's my best guess. Let's actually graph it and see what it is. Y equals 2x minus 3. Y equals 2x minus 3. That's the best I've ever done. I'm like some sort of supercomputer. Hacker. Hacks. No, it's just all skeins. So that's our normal line. We go perpendicular to the line at that point. So if we zoom all the way in on the point, what we'll notice is that it's perfectly 90 degrees. Which is the whole point. That is what the normal line is. It intersects our function. The red line was our function. The green line was our normal line. All right, I feel good about that. I can go to bed now and feel good about myself. I'm not going to, but I could. That's what the normal line is. So assuming that that's okay, we're going to do another one. Example, find the y-intercept of the line that's normal to the curve. So the y-intercept of the line, that's a bit of a different one. It's saying what's b. So we'll find b. We'll actually find the final answer too. We'll find the equation as well. And said normal to the curve. We want the line normal to the curve, which means the normal line of the function. And we've been given the point x equals 3. All right, the first thing I'm going to do, I'm just going to say before we start, find y. The reason I'm saying to find y is because we're not given it. You see this x equals 3? It didn't give us the y value. And I know we're going to need it later. When we do y equals mx plus b, we need to put a y and an x value in. So we might as well get the y first. We could get it later, but let's do it now. So when x equals 3, y equals 2 times 3 minus 1 over 3, 3 cubed. Just in case you're lost, I'm just putting it in here. This is the function I'm putting it into. If you solve that, you should just get that y is negative 3. So that's my first step. I should definitely, that's an important step. What that means is that my point xy is actually going to be, when x is 3, y is negative 3. Okay. That's our x and y values. So I put a hint there, find x and y first, but this is what I did. This is what I mean by that hint. Okay, and now we can start. Let's get the derivative. The derivative is very easy. What is it? 2 minus 3 comes down, so 3 over 3, it'll cancel, so that's just x squared. I'll make a side note here. If you have a function like this, negative 1 over 3 x to the power of 3, and we want the derivative, notice that the 3 comes down and subtract by 1. So it would be negative 3 over 3 x to the power of 2, which is actually just negative x squared. That's why that works out the way that it does. Okay? So with that in mind, this is our derivative. What's our next step? Hopefully you're awake, paying close attention. Second step is always sub x, yep. If we had y as well, we would put in y. But it just has an x here. There's no y's on the right side of the equation. So just sub in x. The derivative when x is 2, no, sorry, when x is 3, is going to be 2 minus 3 squared, which is just negative 7. Excellent, good job, negative 7. That's 3 minus 3 squared, so, 2 minus 3 squared, 2 minus 9. 2 minus 9 is negative 7. And that gives us the slope of the tangent. But we don't want the slope of the tangent. We want the slope of the normal line. So we need to do the negative reciprocal. The negative reciprocal, make it negative. It's already negative, so positive. The normal, careful, negative reciprocal. Make it negative, and the reciprocal means flip the fraction. So if it's 7 over 1, it becomes 1 over 7. And that's a positive. Remember, that's negative reciprocal. Clear? Is that okay, Mohammed? Because you said negative 7. Is it better now? That's our negative reciprocal step. Why do we need that? Well, we can't build the function without m. So use y equals mx plus b to continue. Let's see. Y is negative 3. X is 3, and b will be given. So let's just write these in. That's negative 3 equals 1 over 7 times 3 plus b. And now I can solve for b, which is my y-intercept. If you rearrange this, what do you get? Well, it's negative 3 minus 3 over 7, which is negative 24 over 7. That's my b value. So that's actually the answer. It asks for the y-intercept. So that would be our final answer. But really, the more important answer is the equation. So I'm going to say, if asked, the equation is this. And there's no harm in writing it out. So mx plus b, mx minus 24 over 7. So you said 1 over 7x minus 24 over 7. Perfect. That's exactly what the answer would be. And again, students ask me, how do we check this? And I just always say, use Desmos. There's no reason not to. It's not difficult to write these things in. You just write in the function, write in the point, and write in the normal line, and you can check your own work. So I'm going to do those 3 steps. Write in the function. Doesn't matter how crazy it looks. X cubed. So this is my function. All right. The point 3 and negative 3 should be on it. So again, that is confirming that my point is correct, because I can see it's right there on the graph, right there. And then I can draw my normal line, which should be perpendicular at that point. So again, if I do this freehand, which I don't expect to go as well as last time, I would say, nope, really steep like that. And then if I do the normal line, something like that. All right, so when I put in my normal line, I should get something really close to that. Minus 24 over 7. Almost the same. Not perfect, but very, very close. So even by inspection, I knew that that needed to look like that, but the math confirms it. Hopefully you can see that it's not so bad to graph this stuff. You have the original function, the tangent line we didn't get, so we don't know what it looks like, or we don't know what it is, but we got the normal line here. All right, easy peasy. On a scale of 1 to 10, how are we? This will be a good chance for me to check who's actually here, because I've been checking who's actually here now. So just type a number in the chat or say hi, anything, so I can confirm that you're here. And then anyone who's not actually here, I'm actually going to kick them out because I'm evil. So Hamza, Kevin, Ibrahim. So we have Ali, Muhammad, Al-Maki, Hamza, Kevin, Ibrahim. Is that everybody? Let's see. Kevin, Muhammad, Salah, Salah, you there? You there, buddy? You there, Salah? Okay. Cold. So cold. Nothing personal. It's just students are signing in and just leaving their computers to go see a movie or something. And we're starting to crack down on it a little bit. Better late than never. All right. So I'll leave this to you. Would you like me to do another practice problem on the tangent or the normal, or would you like me to move on to the next topic? I'll just ask you. One more, please. Okay, that's enough. If one of you wants another one, then I will have one more. This first one, you'll notice that says, find the equations of the tangent and the normal line to the parabola with a vertex at 0, 3 and a focus at 0, where x is 1. So you would need to get the formula for the parabola and then get the derivative, put your points in, get your tangent and your normal. That is way too big. It's a ridiculous question. It's a big challenge. It's not impossible. It's just, what? Seriously? No, I'm not going to ask you that. That would be university level stuff. And we're not at a university. Let's keep it practical. So for now, you can take a look at the solution if you want, but let's just pretend that's not there. We can either do 2 or 3. Which one? They're both equal difficulty. We can do them both if you want. Would you want to do 2 or 3? Which one? You can almost flip a coin. Doesn't matter to me. Both. Okay, let's do both. Why not? Let's do both. Find the normal to the curve. So once again, we want the normal line. Find the line normal to the curve at the point given. So I'll follow my regular steps. Derivative. You obviously don't need to write all these steps out. I write it for you. Y prime is 6 minus 4x. Done. Second step. Substitute in your x value given. So in this case, we have x and y. So the y prime at x equals 2. 6 minus 4 times 2. That should be what? 6 minus 8, negative 2. That means our slope of the tangent is negative 2. That's not enough. I need the slope of the normal. And it looks like you got it now, Muhammad, 1 over 2. That's perfectly correct. Third step is the negative reciprocal of the tangent. The fourth step now is the same as before. Use y equals mx plus b. What's our y? Our y, let me write it out first. Y equals mx plus b. Our x value is 2. Our y value is 4. Our b value, or sorry, our m is 1 over 2, so I can even color code that if you want. That gives us a b of 3. That's exactly right. A half of 2 is 1. 4 minus 1 is 3. And now we have all of our pieces. All we need to do is graph it. Sorry, not even graph it. We just need to write it out. mx plus 3. I won't graph this one, but I could. Yeah, absolutely. I would like you to do 3 alone, actually. So what we'll do is take 4 or 5 minutes if you need that long. As soon as I see 2 or 3 answers in the chat, I'll come and show my solution, okay? So let's take a couple minutes and try number 3. 2 to 3 minutes max. Yeah, it's only 2 to 3 minutes max. Give it a shot. I'll be watching. As soon as I have a couple answers in the chat that I think are correct, I'll show you my answer. That's correct. So that was quick. I'm impressed. So shall I go through my solution just to make sure that everyone's clear? Find the line normal to the curve, find the normal line. It's given a point. First step, find the derivative. That's the derivative. Sub in x. Put x in, get -3. That means the tangent's -3. The negative reciprocal of -3 is a negative negative, which is positive. So negative positive 1/3. Fourth step, use y equals mx plus b. That's my y, that's my m, that's my x, that's my b. Solve that, 28/3. Final answer is this. So if you want to see the graph, here we go. So that's definitely the normal line at the point -1 and 9. Same answer as me. So congratulations to those of you that got the same answer. Those of you that are working in the background but didn't give your answer, hopefully you're actually giving it a try. It'll be good practice. What would it be practice for, you say? Well, I'm glad you asked. On the assignment, I would perhaps expect a question on the tangent line. So if I were a betting man, I would say that someone should expect a tangent line question on the assignment. And perhaps if, I thought about it hard, I would probably say that on the test, you would expect a normal line. Who knows? Who knows? I would say, I'm just the instructor. What do I know? But on the test, I would expect the equation of a normal line, like we just did. On the assignment, I would expect the equation of the tangent line, which is slightly different. So Ali, is it the same thing? Tangent and normal are two different questions. Normal involves the extra step. So let me show you. If I ask you the normal line equation, you do what we just did. And Hamza, you said tricky question. I'm not going to make it too tricky. It's just basically the same steps. I'm not trying to make it difficult. Just expect it. The tangent line, you'll notice, is the same steps. You just get one less step. Derivative, substitute, go directly to y equals mx plus b. We did not change the slope of the tangent line, all right? That's the only difference. So great job. Nothing comes in easy. Well, every now and then I like to throw something in just to make sure you're paying attention. A little bonus for those who are actually coming to class and listen to the things I say. Speaking of bonus, I'm putting a bonus question on the test, or on the assignment, which I normally don't do. There'll be a 3-mark bonus question. Who knows what it's going to be? Could be anything. It can't be anything. It'll be a derivatives question, but there's a bonus. Maybe I should make the bonus like, what's my middle name? Let's see. Does the parabola, ellipse, etc. matter on the question? No, it's just a little extra piece of information. If it says hyperbola, whatever, just extra. It's just extra. You don't need to know what it looks like to get the answer. You don't need to know at all. So this, I would just say, do this for homework, do this for homework as practice for the assignment. All of the full solutions are online now, so there's no reason to worry about that. This question is a bit of a challenge. I would not worry about this for the assignment or the test. It's just a little bit of a challenge. If you're curious about it, go see the full solutions online. It's not difficult, but I'm not going to cover that. So we have one more topic left. Any questions before we go into the very last topic of the unit, which is actually physics? And I like it a lot because I'm definitely a physics guy. I have a degree in math and physics, but as some of you know, I also teach physics. I'll be teaching physics next semester again, I think. And it's just my jam. I like physics. So the derivative as an instantaneous rate of change. what this means, first of all, I'll give you a nice picture. All right, I've got a QR code if you want to follow and a link, but let's look at this. Okay, first of all, let's zoom this back. Imagine that this curved line, imagine you're in physics class, and this curved line is telling you the position over time of, let's say, a car, all right? So in the left side, we have something that is going in the negative direction, but slowing down. And as it gets further and further to this point, it's stopped, I guess, and then it's going further and further away from where it started. So just to make life easy, let's ignore this part of the graph, ignore that, and just imagine you are moving away from your home base. So you start moving, and you're running away, and then at this exact point, you have a velocity. At that point, you have an exact speed. You're accelerating. All of this is acceleration. You might know that there's acceleration when we have this form. At that exact point B, what is my velocity? Well, it's easy to find, actually. It's the slope. The slope of the position time graph is velocity, which you actually should know from physics already. And I'm getting to the point. If your position is s, what's your equation for speed? Sorry. If your speed is, your displacement is s, speed or velocity is displacement over time. Let me get to the point. Let's just say we were going different speeds at different times, and at this exact point, what is your speed? It turns out you find your speed by knowing the tangent line. So the derivative at this point, the slope at that point, is your velocity. Let me make it more clear. I just wanted to show you visually. You get the slope at that exact point. That is the slope or the velocity of the object at that time. Let me make some notes here. Maybe try and make it a little more clear to you. Let's think back to physics. And I'm sure you've all done physics. I taught some of you. I taught Hamza at least. Think physics. We have an equation, displacement. Displacement is v1 plus 1/2 at squared. You might remember this is called kinematics formula. So let's just imagine that we have some variables here. What's the derivative of this? What's the derivative of the displacement? Just take this as it is. Maybe you don't know yet, but the derivative here, treat v1 like a constant and t like our x, it would give v1 plus. You bring this down, multiply it, it cancels, it leaves a and t. What's this? This is v. So it turns out that our kinematics formulas, you don't need to worry about this part, this is just for extra information. But our kinematics formulas, where they come from is the derivative. If you get the derivative of position, it's velocity, which is something we never got to talk about in physics class. And if you go one step further, you get the derivative of velocity, it's actually acceleration, which that would cancel this, and it just cancels this out. Acceleration is equal to acceleration, which is not helpful, but at least you can see that it matches up. So in short, if s is position, then the first derivative of it is velocity. It's the position over time at an exact point. Your second derivative is actually acceleration, also known as a. These are big ideas, actually. You'll find that this section is really, really easy when you actually see the equations, but it's powerful stuff. Let me just make it clear to you. The derivative of function can be interpreted as the instantaneous rate of change, the exact rate of change or exact velocity at a certain time with respect to a variable, or in other terms, given any position function, s of t, we can find the corresponding velocity function. Just get the derivative. Let me finish going through the definitions here. The instantaneous velocity, what is it? It is the derivative of position. What is the instantaneous acceleration? It is the derivative of the velocity, or the second derivative of the position. Let's see what this looks like. Find Vt and At for each of the following position functions. Okay, I'm not going to make this complicated. The velocity is the derivative. What's the derivative of 48t plus 12? 48. Done. What's the derivative of 48? 0. Okay. That was nice. I'll recap it in a sec, Mohammed. This is the first derivative. This is the second derivative. Okay. So, Mohammed, you said you're confused. Let me try to simplify it in a different way, or explain it in a different way. This function, if you were to graph it, it would look like this, okay? This is our displacement, or sorry, our position. So over time, this person's walking further and further away. You just need to know the shape. From physics class, you should know that this is a constant speed. From our equations here, we can see that speed is constant. It's going to be 48 meters a second. From our graph, is this person accelerating? Well, he's not accelerating because he has a constant speed. So it has 0 meters per second squared. In other words, given this position function, the first derivative, by definition, is the velocity. So we can say it's 48, it's constant. It's a constant, so it's constant speed or constant velocity. If acceleration is 0, then it has no acceleration. I'm just trying to make connections between the math stuff and the physics stuff. So in short, if you're given the position, you get the derivative, it'll give you the velocity. So if that's fully described, if this is telling you the position of something, you don't need any other information. You just get this derivative, it'll tell you the speed at every single point. That is hugely, hugely helpful for physics, eventually. If you know the position, you can also automatically get the acceleration. You just get the second derivative. Let's show you what I mean. Let's do the next question. The position is this. What's the velocity? It's the first derivative. What's the first derivative? Well, 8t minus 4t cubed. That's our velocity of whatever this is at any point. The acceleration. Actually, before I show the acceleration, I just said that this is the velocity at any point. So if that's true, for example, let's just say at time equals 1, what's the velocity? Well, you would say velocity at 1 second is 8 with a 1 minus 4 with a 1 cubed. And that works out to 4. So at that time, it would be 4 meters a second. Am I making sense? Can I just have a comment to see if this is making some sort of sense? So you have the position. The position function is s. Get the derivative. That's now the velocity. We can now know the velocity at any time. You don't need your kinematics equations anymore. They're not useful. You already have everything you need. So this is 4 meters per second, for example. Let's get the second derivative. So Ibrahim, I just said, for example, e.g., if time was 1. Yeah, I just came out of the top of my head. Yeah. the first or the second derivative or the first derivative of velocity is 8 minus 12t squared. All right, this is the first derivative of the position. This is the second derivative of the position. Yes, Mohammed, you said hold up. You're confused by acceleration. Okay, what's the derivative of 8t? 8. Okay, all right. So 8t gives 8. You got it? Did you have the aha moment? Yes. 4 times negative 4 gives negative 12. I'm just doing derivatives, one step after the other, right? The only difference is that it has t. So make sure, you can even do these on the side of your page as x's, to be sure. It's the same exact process. Sorry, my computer's going a little slow here and fighting me as usual. But yeah, like think of it this way, 8x minus 4x cubed. There's no way you'd have problems with that. That's 8 minus 12x squared. We've been doing hundreds of those. So I know you can do it. And that's why we have this. Same thing. Okay. Same idea. What if I asked you, what's the acceleration after 1 second? We don't know what the object is, but what if I wanted to know what the acceleration was at 1 second after it started? So you just put 1 in. Put 1 in, it would be 8 minus 12 times 1 cubed, 1 squared. So 8 minus 12 is negative 4. So it just happened to work out to 4. Of course, it could be anything. But we know a lot about this position function just by doing derivatives. All right? Do C. Doesn't give you much space, but you don't need much space. Sixty squared. Perfect. Now you're getting it. Anyone else? What's the next one? 6 minus 12t. That's exactly right. Great job, Ali. Great job, Mohammed. I hope that the others are still conscious, still alive, still happy and healthy. Hopefully. Okay, that's it. That's the concept. We'll do a few more examples that are based on this concept, but it doesn't get more difficult, at least in my opinion. So long story short, position, first derivative, velocity, second derivative, acceleration. Let's do it. So Ibrahim, you say it's just simple derivative. What's the point? What do you mean? It's the same thing, but it's an application. So what we've been doing earlier, we have some mystery function and some answer that just talks about some general slope. We're just talking about steepness. But some students are like, who cares? You might still be saying, who cares? But now we have a position. It's something that describes motion. It could be an airplane. It could be a person running. It could be someone playing football. It could be a spacecraft. It could be something. It's its position versus time. And by doing the derivative, it's no longer just the slope. By doing the derivative, we can tell you how fast it's moving at any time just by knowing where it is. You don't need any other information. Or you can get another derivative on top, and it'll tell you the acceleration of that object at any point. So that's the reason. We've moved from general math into physics, and we can describe things. So that's the difference. Same procedure, which is a good thing for you, but this is why we have an application. In fact, almost every single math concept has a direct connection to physics and vice versa. But we don't always get into the physics part. All right, let's do a question. Calculate the velocity and the acceleration of an object whose path is described by this function when time is 6. Okay, so let me make a little sketch. This is actually a parabola. It's projectile motion. It looks like this. We want the velocity and the acceleration of this object when time is 6. If you did this a long method in physics, it would take a lot longer. The velocity is not negative 104.06. Let's see why. So the velocity function, by the way, you might notice, maybe, that this is this, which you saw a lot of in physics. And then you'll hopefully notice that if you get the derivative of that, it gives you this. Where do you think this term comes from? What is it? What's this term? Not just velocity, it's gravity. It's negative 9.8. Acceleration of gravity. So these concepts that we're talking about now, even if you don't know what we're talking about, you can connect them to physics. So I'm not going to ask you to connect it to physics, but it's important to at least think about it. Anyway, the velocity is 40 minus 9.82. And it says I want the velocity at time 6. So let's go ahead and put in time equals 6. Well, I get negative 18.8, yeah. Mohammed, how did you get 104? Did you square it, maybe? Okay. So that's our velocity. That's the velocity part done. What's our acceleration? The acceleration is the derivative, negative 9.8. Huh. Interesting. Because this is a constant, it just got deleted, and it left me with a constant for the answer, which makes sense. If you remember back to your physics, if you can remember back then, this is the acceleration of a projectile. In projectile motion, our acceleration is always negative 9.8. So even though the time is changing, acceleration when time is 6, well, it's still negative 9.8 because there is no t term. There's no t to substitute in. All right, there's no t value in that equation, so it stays the way it is, which, if you remember your physics, is totally consistent with what you've learned. The acceleration when something is traveling through the air doesn't change. Gravity doesn't just turn on and off. But this is it. These questions are pretty short and sweet, right? I'm assuming you're not having much trouble with this. How's it going? Going okay? Yep, I agree, it's easy. So we'll do, let's see, we'll do one more question and we'll be done. And then I'm gonna do, what I normally do not do, and I'll do a review for the assignment. I'll do a whole practice assignment so that you can see everything again one more time. And then we'll be done for the day. Yeah. You're welcome, Hamza. It's all for you. Example. So this says a projectile is fired vertically upward with a velocity of 44 meters per second. Once again, you can think of the projectile like this. Velocity of 44. Okay, the distance s meters above the ground of the projectile is given by this equation. Really, this is all we need, I think, where t is in seconds. Find t when v equals 0. Or in other words, how long does it take to reach maximum height? You might actually remember this from physics. When something's at maximum height, v is 0. That's how we know this. But let's just assume we didn't know that. So if s, or position, is this, if this is position, velocity is the first derivative. 44 minus 9.8 t. Does it ask for acceleration? No. If it did, it would be 9.8, negative 9.8. What it does ask for, this is our equation, it says find t when v is 0. So we need to set this equal to 0. Or in other words, when v is 0, what's t? This is the whole point of the question after all. So set v equal to 0. 0 equals 44 minus 9.8 t. Bring it to the other side. Divide by negative 9.8. Should get 4.49 seconds. It is a fraction, but I'm not keeping the fraction. So you rounded to 4.5, no need for that, because it's already such a very small, it's already a complete number anyways. If it was 4.499223456, you would round it, no need to round. It's already so small that there's no need to round that. We only round to make it smaller or to make it easier to read. If you want to keep the fraction, you can, but you know, if you have a stopwatch, you're not going to say, hey, it's 220 over 49 seconds. Someone would look at you very strange. You just say 4.5 seconds, 4.5. Is this our answer? Did I answer the question? Yes. So what should I do next then, Ibrahim? Let's see, it said find the time and velocity is 0. Well, I put velocity equals 0 in, and I solve for time. I would say I'm done the question. There's nothing left to do. There's no normal lines, tangent lines, nothing else. I'm finished. Okay. So, would you like to start the review of the assignment now, or would you like me to do one question more, 2 questions more? So, one of you wants me to do more, one of you wants me to do the revision now. Okay, one more. All right. The revision won't take that long, actually, so I'll do one more question. Let's see. First of all, this question I'm not going to do. I'm just going to make a note that if I were to do it, you would want to change the form first and then do it, right? That's what I would want to do. Let's see. Let's do 2. I'll do part of 2. This first one's a challenge question. I'm going to skip it. It's not really that important in my opinion. I'm going to do B and C, and we'll move on. Find the instantaneous velocity when time is 5. Well, the velocity is negative 9 plus 28t. I'm looking at the position function and getting the derivative of it. Let's not forget that it's the first derivative of the position. That's what velocity is. So time is 5. So negative 9 plus 28 times 5. We calculate that. Plus 28 times 5. I get 131. The units are extra. I just know it's meters per second. Is it negative? I don't think it's negative, Ibrahim, because the negative 9, but then you're adding 140. Negative 9 plus 140, which gives a positive. Me too, actually. It's not mentally not having the clearest day. But we'll all be okay. We'll get a break soon. So that's my 5. We want the instantaneous velocity in this one, acceleration in the next one. So just get the second derivative, which is what? 28. And there's no need to substitute. All right, 8 seconds. There's nothing to substitute in. So Mohammed, you're saying 0. It's not 0 because this is our first derivative. We have a t here. The t will be deleted, but it will leave the 28. Yeah, 28. So there's no t to substitute in, which means, I guess I can keep that there actually. It's still 28. All right. As usual, when I introduce these things, sometimes I confuse you, and that's not my intention. My intention is to give you some background as to why we're doing what we're doing. But at the end of the day, all you really need to know is what I've put directly in the questions themselves. So if you can do the derivatives, substitute your time, you've done everything you need to do. Cool? Cool. All right. Let me just do a quick attendance check. You all still here? There's only 5 of you. Ali, Hamza, Ibrahim, Kevin, Mohammed. I think you're all there. Yeah, you're all there. You're all good. You're the core. What I'm going to do is jump to the revision sheet that I made. I haven't posted on D2L. I will, if I remember. But it's called Assignment 5 Practice. And I just took some old assignments, made a new assignment. Oh, geez. Took the old assignments, made a new assignment out of it. And it's not the same as your current assignment, but it's similar. I'm not going to give the same questions, obviously. Let's get started. Use the graph below, so clearly this. Use this to determine each limit. So it says, what is the limit as x approaches -1? So you go looking for -1. Be careful. This is y equals 0. Or sorry, x equals 0. So this is x equals -1. What's the answer? Well, just you had to look on the left and the right. From the left, on the left side, it says it's going to 1. From the right side, it says it's going to 1. The answer is 1. The limits from the left and the right are both going and saying that it's going to be 1. That's our answer. Clear? You remember this? Okay. From in part B, and there's no other work to do, especially when you're given the graph, it's pretty simple. The limit as x approaches -2, that's talking about this asymptote. I can see right now, just by looking at it, it doesn't exist. Why does it not exist? Well, it does not exist because the limit from the left is telling me it's going to -infinity. The limit from the right is telling me it's going to +infinity. And if those two limits are not the same, if they're going in opposite directions, then they can't be saying it's the same limit. So it needs to be non-existent. It doesn't exist. The limit does not exist. All good? Again, there's only 5 of you right now, so I want to make sure that you're getting your questions answered if you haven't. So that's your limits if you're given a graph. There's different ones. Make sure you go back in the notes and take a look at some of the other examples I did. You need to be able to get 2 limits from a graph. I'll give one similar to this, but different. Let's evaluate. First things first, this limit, the first thing you should do is try it directly. Just sub in your values. And in this case, we have 2 times 3 minus 6 all over 3 times 3. Why am I using 3? Well, because 3 is the number that we're approaching. That gives me 6 minus 6 over 9, which is 0 over 9, which is 0. Actually, that's okay. Kevin, yeah, I'll post my written solutions here. I'll post the original and I'll post what I've done today online. Okay. So is this okay? Yes, it's okay because it's a 0. The things that are not okay are if we get 0 over 0, infinity over infinity. Those are our two bad cases. Mohammed, you can write 0 directly, but it's better you at least show a little bit of work, because if you were to show 0 and it's not right, then you would lose both marks. At least if you show a little work, I can say, all right, I'll give you a part mark for this or part mark for that. But if you're super confident, 1,000,000% positive that it's going to be 0, you can write it directly. I prefer seeing the work. Okay, the next one. What would happen if I do it direct? We would put in the 4, yeah? So it would end up being 16 plus 4 times 4, 16 minus 32. It would end up being 16 minus 16. That's 0 over 0. We can't do that. We're not allowed to do that. Limits don't allow us to do 0 divided by 0 because it doesn't make sense. We need to do something else. What's the next step that we try when we can't do it directly? We're going to do it algebraically, so we're going to factor. So we're going to try to factor out and see if we can cancel the discontinuity. Let's see, limit as x approaches 4 of factor the top and factor the bottom. Okay, first things first, the top. We want numbers that multiply to make 32 and add to make 4. Yeah, so 8 and 4 sounds about right. I'm just going to write it out for those of you that are not so confident. What are the factors of 32? Well, 1 times 32. You could also say 2 times 16. You could also say 4 times 8. And because the value is negative, one needs to be negative, one needs to be positive, and they need to add to what looks like positive 4. So this needs to be positive 8 and negative 4. It's because negative 4 plus 8 is negative 4, positive 4. And negative 4 times 8 is negative 32. I don't normally review that, but just be careful. X and X, negative 4 and 8. And the order doesn't matter, 8 first, 4, whatever. On the bottom, this one's tricky if you don't understand difference of squares. What you're going to do is get the square root of this, which is x, and then you're going to get the square root of this, which is 4, and then a plus and a minus. So just so we're clear, square roots, difference of squares. Now I've seen what you said, and I think you're right. The 4's, x plus 4, x minus 4 on the bottom, yes. And now cancel, be very careful that you can actually cancel, and I can see now x minus 4, so I'm okay. I can continue. You could skip this step, but I don't like to skip it while I'm working on it for students. So I'm going to do my direct substitution now. I'm going to replace the x with 4, and there'll be another 4 on bottom. Oops. This is 12 over 8, which is what? 6 over 4. if I'm awake. Something feels weird about that. Is it 6/4? I think I just had a, oh yes, 3/2. I knew something was going weird. All right, so you don't need to write all the steps. You can just write the key steps if you want. But the more steps you write, the more chance I have of giving you the marks that you deserve if you make a mistake. So just be careful. And just so you're all clear, this is my direct substitution step. All good? If it's a number and you're not dividing by, if it goes 0/0 form, try factoring first. So that would be my first point of advice. Let's keep going. If you need me to go back, I will. In this case, we have infinity. So what you'll notice, hopefully, if you try to do this directly, you'll end up with infinity over infinity form. And if we get infinity over infinity form, what we're going to do is divide by the highest power in the denominator. In the bottom, I guess. Denominator, bottom, whatever you want to call it. What's our highest power on bottom? Just so we're all awake here. It is the x squared. Squared is the biggest. So we'll divide everything by x squared. Divide every single term by this. Maybe some of you are already working on it. Take the limit as x approaches infinity. Divide everything by x squared. So this is 3 over x squared. Minus, what's 2x squared over x squared? Just 2. X squared over x squared is 1. And then we have 3 over x. Before I move on, can I just get a general idea of how we're doing with this? I need my coffee water combo here. Do you need me to go through any of the steps more closely, Ellie? Okay. Now all I need to do is do direct substitution. And what's going to happen is if I take this infinity and I put it in for this x and this x, it's going to be a number divided by the biggest number in the universe. So both of these numbers go to 0. And what ends up happening is I have -2 on top and 1 on bottom, which is exactly what Ibrahim said. The final answer is -2. The limit is -2. And if you wanted to, if you graphed that, you would see it as well. All good? Hopefully all good. So we've done a number of different things now. If it's the limit towards a number, you do direct substitution first. If that doesn't work, you factor. If you're going towards infinity, do this. And the last case, let me know if you need to go back up. The last case is when x is going towards 0, and that would cause this to be divided by 0. Let's just see what happens. I've told you can graph this. If you graph this on Desmos, it looks like this. All right? But we can also do it directly. You have 0 plus 5 divided by 0 squared. Well, actually, it's not 0. I'm going to say on bottom, it's an extremely tiny number. When it's on top, it doesn't matter. We can call it 0, okay? But on bottom, it's actually approaching 0. It's going close to 0, but it's not 0. So imagine the smallest possible positive number you can. And let's just imagine that this is like 0.00000000000000001, for example. In other words, you have a number on top divided by a tiny, 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 tiny number. What do you get? Well, if you actually work this out on your calculator, what's 5 divided by 0.000000000? Ibrahim, it actually doesn't matter in this case if it's negative 0 minus or not. It would give like 5,000 billion, 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 billion. It would be massive. It's 5 with unlimited number of zeros. What I'm trying to say is it goes to infinity. That's our answer. But a much easier way is to look at the graph, which I'm telling you you should do if you're dividing by 0, and just say, hey, as it goes to 0, we go to positive infinity and positive infinity from the left side and the right side. So we have a limit of positive infinity. Or if you want a short way to do it, when you're doing limits, generally speaking, this will often happen. If it's in 1 over 0 form, the answer will give infinity. I'm just trying to give you some shortcuts. It doesn't always work, but if you go back and do the examples in the notes, you'll see that for this form, it often does work. I also gave you another tip. I said if it's like a constant over x with an even, it gives infinity. Plus or minus, depending. But it's better to graph it. If it's plus or minus some constant over x to the power of an odd, it doesn't exist. So lots to think about, but long story short, if there's an x on bottom, probably going to infinity if the x is going to 0. That's a tricky question in a little package. Let me summarize it. Please graph. If you graph it, you'll see that it goes to infinity at 0. All right, let's do the next question. Use the definition of the derivative. Everyone loves this question. And in fact, if you've done enough practice, it will not be difficult. Use the definition of a derivative, also known as the delta process, to determine the derivative, that's what the delta process is, of that function. And you'll notice you've been given the formula. So that's nice that you've been given the formula. Let's consider what our function is. Okay, let's write out our functions. We have f of x. What is f of x? It's x squared plus 6. Let me go one step further and remind you what the next step is. This formula is going to need f of x plus h. What's f of x plus h? Well, we take our x, replace it with x plus h. Anytime you see an x, replace it with x plus h. So x plus h squared plus 6. You take those answers, put it into your formula, and the rest is just algebra. You with me so far? Hopefully. So the limit as h approaches 0, I'm going to put in f of x plus h, this, plus 6, minus x squared plus 6, all over h. Now this is my chance, or your chance, to show me what I did wrong. I did one tiny little mistake here, and it makes a huge difference. You can't even solve the question unless you fix this mistake. Brackets. Yeah. So the problem is I'm subtracting this whole function, which is all of the original function. If you're subtracting all of it, yeah, you need brackets. Otherwise, you're only subtracting the x squared, and the 6 is kind of just hanging out there. So very, 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 very important. What that'll let you do is multiply through by the negative, and you'll get the answer that you're looking for. Speaking of which, well, let me show you this. Our first function, f of x plus h, is of course this, which is why I wrote it here. Our second function, f of x, is this, which is why I wrote it here. So hopefully you can match the form. What is my answer going to be? What is my final answer? Before I go any further, what is the derivative of this? What's the derivative? 2x. So we know before we even do the delta process, because we have the skill set now, before we do the delta process, we know the answer has to be 2x. So we know before we even start that if we don't get 2x, it's going to be a mistake. So let's get started. Let's expand out the first term. You should know what that is by now. It's the first term, so you don't need brackets. Plus 6 minus x squared minus 6. That minus is extremely important. Many students miss it. So be careful. All over h. And let's do our canceling game. Let's take a look and see what can cancel. X squared and x squared. 6 and 6. Sorry, 6 and negative 6. Let's see what's left. 2hxh and x squared. So I'm going to factor out the h. 2x plus h all over h. I see more h's. Goodbye, h's. Hello, limit. So the limit as x approaches 0, 2x plus h. And now I'm going to do my direct substitution, which will bring the h to 0. There's nothing wrong with it. I'm not dividing by 0 or anything. So this becomes 2x plus 0, and I get exactly what I thought I was going to get, which is 2x. For the final answer, 2x. I know that because I just used the power rule on this one. I just got the derivative of the original expression, and I can check my final answer. If I didn't get that, you know you're wrong. You just go back, try to find your mistake. That's probably the fourth or the fifth one of these we've done. How do we feel about that? Is that okay? Gotta do my daily stretch. Mohammed was okay. Thought maybe a cat was in here. Okay. This is question 6. We're going to do a few more questions, but they won't take long. I'm not giving you this crazy, big, intense assignment. Although I did decide, yeah, I'm tired too. I did decide that I'm going to give an hour to do the assignment, just so everyone can have time. Yeah, we watch the limit videos, it's okay. Let's move on. Determine the derivative for each of the following functions. I'm going to extend this question just so that you have a little bit more practice. Let's just say we had an e squared here and 2 pi, the cosine of pi. Let's try to do the derivatives, because it says determine the derivative. Y prime is 10 x to the power 4 minus 7x. What's the derivative of 7x? It just deletes that x because it's 7. Plus, what happens with the square root, you may ask? Let's force it into power form, which is going to be 2 outside of x, power 1/2. You don't even need that bracket, actually. It brings the 2 down. Sorry, it brings the 1/2 down. X negative 1/2. Be careful with that. As a side note, if you had x to the power of 1/2, the derivative is going to be 1/2 x to the negative 1/2. which is why if there's a 2 in front, whatever, it doesn't make a difference. And that 2 will cancel later, okay? So I can already see it. I'll make a note for it for later. That'll cancel. What's the derivative? I put this here for a reason. What's the derivative of e squared? E to the him says 0. Anyone else? E is a constant. E squared must also be a constant. The derivative of a constant is 0. So good job with that one. 2 pi. Well, pi is 2 pi is also a constant. So the derivative of a constant is 0. Cosine of pi. Cosine of pi is also a constant. They're all 0. They're all constants. So the derivative of those are 0, okay? The derivative of constants are 0. Salty. So salt. So salt. You know what that is? No one got that? No one saying salt bay? I don't have the muscles, but I got the position. All right, let's give the final answer. I'm going a bit slow now. I know you want to probably finish up. All right, that's that. I just simplified the number in front of the x and got rid of all the zeros. No need for those. Let's keep going. We got more to do, and I don't want to take until 5:30. I'll finish a little earlier than that. What's my rule for b? Well, it's 7b. The function is p of x. It could be called anything. It doesn't matter what the letter is. Product rule. That's exactly right. First function, second function. I'm going to write out the product rule for the last time, hopefully. It's the product rule. We know what that is. I certainly hope you have it memorized by now. And of course, the first one is our f and the second one is our g. So we just go through the motions and figure out what the answer is. You only need one line. Derivative of the first one. Times the second one. Plus the first one. Times the derivative of the second one. All done. It says very clearly, do not simplify. If you simplify, you're just wasting your time. It's worth 4 marks. That seems like a lot to me. So I don't know, maybe I'll work worth 3. But generally speaking, when I mark this, 1 mark for the first derivative, 1 mark for the second derivative, 1 mark for actually using the product rule appropriately, and 1 mark for making no mistakes. That's the general marking process. Let's move on to C, because I know you're probably getting tired at this point. I can see in this question that there's a top, there's a bottom, and so that would be F divided by G. What do you think I'm going to do? I'm going to do the quotient. 1 mark for not cheating. No comments. I'm so sick of this. Not sick of you, I'm sick of some students cheating. I do what I can, but it's like I said before, no one's going to want to pay you to have someone else do the work for you. And when you're doing your job, you're going to be expected to actually know something, not other people to know it for you. Anyway, I'm not getting into that right now. Let's use the quotient rule. So this is G prime. So don't get confused. This G here is not the bottom G. They just have the same letter, just a coincidence. Don't let it confuse you. Just pretend it was something else. Pretend it was F, pretend it was whatever, it doesn't matter. the derivative of the top one, 2x plus 2. What was the bottom one? Minus the top one and the derivative of the bottom one. And don't forget the fraction. Some students forget to write the fraction. It's the bottom. And another thing students forget is the square. I'm going to say don't forget this. It's okay, Hamza. Thanks for coming. You can see the recording later if you need to. I'll post this online. That's our final answer. Once again, it says don't simplify, so don't waste your time. There's no reason to simplify. And the marking process is similar. First derivative, second derivative, 1 mark for using the quotient rule properly, and 1 mark for making no mistakes. Let's keep going so that we have a full answer to this, to the whole assignment. 8. Find the derivative of the implicit function. So before I do this, I just want to do a little side note. I want to give you a chain rule question because we didn't actually do one in this assignment, and maybe I'll give you one on your assignment tomorrow. So just a little extra practice. What if you had this? All right, let's just say you needed to get the derivative of this question, of this function. What's the derivative? What's the first thing I'm going to do? It's easy. It should be easy, but I want to make sure that you are clear and comfortable. The first thing you should do is change form. So y is the exact same thing, but if we change it to power form, we can do the chain rule easily. Now we can get our derivative. So the y prime, bring the power down, keep the inside the same. Make sure you reduce the power. Many students forget to do the power. What I actually recommend you do is bring the power down, make your brackets, and then right away make the power, and then fill it in. Because some students, they get so busy making the inside, copying the inside, that by the time they get to the end of the bracket, they forget the power. So don't be one of those students. Make sure that you don't forget the power. And then on the inside, we need to get the derivative of that with brackets. So the derivative is 24x cubed plus 7. And once again, students forget the brackets. You need to multiply everything by the derivative. Remember, derivative of the outside, keep the inside the same, multiply everything by the derivative of the inside. So let's see, 1/2, 6x to the power of 4 plus 7x, all to the power of 1/2, negative 1/2. The rest is right. Yeah. So Ibrahim, you got that negative. Maybe you wrote it down on your paper and you didn't write it in the chat. That's fine. I'm going to say it's a typo. So why don't we change the inside to its derivative? Why is it kept the same? Well, it's a little bit of a complicated explanation, but it's just the way that the chain rule works. Essentially, you're only allowed to do one derivative at a time. So you bring that down, you're just not allowed to do the derivative of the inside. Basically, we do the derivative of the outside, you bring that power down, that's one derivative already. We got to keep inside what it is. It's just the structure of this question. It's actually too complicated for me to go any deeper than that. That's one derivative, right? You did this and reduce the power, you've done a derivative, and then you start another derivative. You can't do more than one piece at a time, so then we do the derivative, okay? That's the best that I can tell you. It's because the structure is derivative of the outside, keep the inside, then the derivative of the inside. There's much more complicated explanations of that out there, but I'm trying to keep it as simple as I can for you. Is that okay? It is the final answer. This is the final answer. And delete this. No need to simplify. Unless I ask you to simplify it, you don't simplify it, okay? So this would be your final answer. You would end it there. So let's do the implicit function. We have this one, and then I think maybe one more question. We just have this one and one more, and we'll be done. For some reason, there's 2 8s on this, but that's okay. Find the derivative of the implicit function. What does implicit mean? Why is this implicit? It's very simple. It doesn't have the form of y equals something. Or in other words, yeah, Ibrahim got it. The y is kind of hanging out here in the middle. And that's a problem. We need to have y solved if it's going to be explicit. It's not solved, so it's implicit. And what that really means is we're going to end up with these y prime terms coming out of things. So let's quickly review what that means. If we had 3x cubed, the derivative of that would be 9x squared. If you have 3y cubed, y is actually a function of x. So it's a sneaky power rule, or a chain rule. You have 9y squared, but then we're actually getting the derivative of this. And the derivative of that is y prime. Bring the power down, keep the inside the same, get the derivative of the inside, which is y prime. And that's our big difference. And I'm seeing in the chat this power rule. I think you're absolutely right. So let me write out the equation so we can talk about it a little nicer. This is our original function. I'm going to get the derivative. So let me get my derivative in this step here. 15x squared. Keep this on the page. This is definitely a product rule, like you said. First function, second function. Think of it as f and g. The reason for that is we have two functions touching each other. X and y are both functions or variables. We need to use the product rule. Ali, you said the power rule. Explain the power rule. Well, if you had 3x cubed, like I had before, the power rule means you take the power, bring it down, and multiply, and then reduce the power by 1. So what we have is 3 times 3 is 9. The x is just x. And then what's 3 minus 1? 2. That's my power rule. As for the product rule, you know it's f prime g plus fg prime. So the derivative of the first one is is 1. The second one as it is y, plus the first one as it is, times the derivative of the second one, y prime. So I'm clear here. First one, second one. Power rule, product rule. Minus, well, this has a y in it, so it's y, 3y squared times y prime equals 0. That's because this is a constant and this is a constant, so they get deleted. So Mohammed, you were right, except you needed to put a plus in the middle. But yeah, basic idea. You definitely need to factor. What we're going to do is we're going to bring anything that doesn't have a y prime term to the other side. So I'm going to bring this to the other side, I'm going to bring this to the other side, and I'm going to factor the y prime terms. But let's clean it up first. First things first, if I bring those two terms to the other side, I end up getting this. Okay, I've just taken this term and this term. They do not have a y prime. So I bring them to the other side because I'm trying to solve for y prime. That's the derivative. I'm trying to get the derivative. What's left is xy prime minus 9y squared y prime. And now I'm going to factor that, like Mohammed said in the chat. So I'm going to factor y prime out. Factor out y prime. What I'm left with is an x and a negative 9y squared. Okay. First step, derivative. Second step, move things to the other side and factor. Final step, divide. We're going to divide everything by this term. Easy peasy, hopefully. Easy peasy. For those of you who are still awake, I can only imagine if I was sitting there having to listen to me. I think the only reason I'm still awake is that I'm the one talking. I'm not sure everyone's still with me. Okay. Let's do the last question and we'll be done, okay? We'll be done the unit, so let's make it count. Final question. Find the equation of the tangent line to the curve. Should end strong, this should be easy. Equation of the line tangent to the curve at the point given, and it's a 4-mark question. All right, let's follow our recipe. First step. What's it going to be? What's the first step? Derivative. And you're absolutely right. We're going to be doing the chain rule. So the first derivative, we're going to bring the 3 down, put it in front. I'll do what I said before. Do the 3, just leave space for the function, and make sure that you remember that you have the 2 up top. Okay? It doesn't matter what goes inside, because we're just going to copy it. So right now, we copy what was inside. We've only done the power rule. And the chain rule dictates that I need to do the derivative of the inside, which is going to be 6x minus 4. All right, that's my function. You were right, actually, Ali. By doing the derivative, we had to do the chain rule. Second step, same as usual, substitute in the x value, whatever it may be. In our case, our x value is 2. So the derivative, also known as the slope, when x equals 2, is going to be, and you don't need to do anything fancy, just replace x every time you see it with a 2. I like to put brackets in because I can put it into the calculator exactly like that. You do what works for you, okay? I can put this in exactly like it is on my calculator and I'll get my answer. All my brackets, everything. Just make sure you're careful. You shouldn't need to do anything by hand. Of course, you can do it by hand if you want to. I would always recommend trying that, but my calculator will give me the answer. It's 384. Good job, Mohammed. So this is my first real important answer. Remember, I'm trying to get the slope of the tangent line so that I can use y equals mx plus b. So if this is the derivative, when x equals 2, that means that the slope of the tangent line is also 384. So I subbed in x, now I have my slope. My very last step is to use y equals mx plus b. If I put in all my values, that's 64 equals 384, which is giant, very, very steep compared to what we're used to. But if you graph this function, it actually makes sense. It's very steep. Plus b. Where did my numbers come from? This is x. Y is 64. And of course, my m value, 384. So all I need to do is solve for b. Oops. B in this case will be negative 704. It's a weird looking B. I'll fix that. Yeah, you divided, Ali. Be careful. Bring it to the other side. If that's our M and B, then we have our answer. Y equals mx plus b. M x plus b, or negative 704. I'm going to do one more thing before I release you. And that's an extension to ask you, what if I wanted the normal line? I might as well give you that now. It'll just be a quick extra practice, and then you'll be free to go, okay? So an extension to this question would be, what's the equation of the normal line? Well, first things first, and Mohammed already mentioned this, I think. Actually, everyone's pretty much mentioned it at this point, now that I'm looking at the chat. First thing you need to do is get the equation of the slope of the normal line, which is indeed negative 1 over 384. Negative reciprocal, yeah? And then you just need to go straight to the y equals mx plus b step. Y is still 64, m is new, x is still 2, it'll just be a new b. This is a super weird b. It's actually going to be 64 plus 1 over 384, which is 24,577 over 384. So something weird happened with yours, by the looks of it. It should be essentially 64. It's not actually 64, it's almost 64. So Mohammed, how do you get 192 on bottom? Something weird happened. Let me write my final equation and we'll talk about what happened there. So mx plus b, m x plus b. You're saying Muhammad's right. Okay, let me check. (64) plus 1 over 384 times 2. I forgot the 2. Times 2 times 2 times 2. Sorry, everybody. I made a mistake. This is still 64, but of a different variety. My bad. Thanks for that. It's amazing that at 5:21 on a Tuesday, you can still process enough information that you can correct me. And that's a great thing. All right, I'm going to end the recording there, and anything else will just be extra questions. So good luck on your assignment, everybody.